All right, so now we've talked about whole numbers, integers, rational numbers, and we talked more about integers yesterday. So now we're going to talk about actually starting to order decimals and percents. So decimals and integers, so both of those things are both classified as rational numbers. Remember our diagram where, just because it fits into, look in our rational diagram below, we're going to put numbers in. So when we have our diagram, the biggest outside one is those are our rational numbers. Okay? Then the middle one, you have your integers, and then you have your whole numbers. So remember, whole numbers are those positive counting numbers. Okay? They can't be fractions or decimals. So when I look at this list, I'm going to go through and look for all my positive counting numbers. So 6 is positive and it doesn't have a fraction or decimal, so 6 is a whole number. Negative 5.7 has a decimal and it's negative, not a whole number. I'm going to skip it for now. Negative 31, okay, it doesn't have a decimal or a fraction, but it's negative, so again, not a whole number. I'm going to skip it for now. 0 is a whole number, right? That's the first one. Remember, positive counting number starting with 0. 17.2, that decimal tells me nope, so I'm going to skip it. 25, it is positive. It doesn't have a decimal or a fraction, so it is a whole number. 42.4, there's a decimal, so no. 100, no decimal, no negative, that's a whole number. Okay, so those ones are done. Now I'm going to switch to my integers. So negative 5.7, it's negative, but that doesn't make it an integer because it still has that decimal. Remember, integers are those positive counting numbers and their opposites. So when I say opposite, I mean negative. So negative 5.7 is not an integer because it has that decimal. Negative 31, however, is an integer because it's a whole number, right? But it's negative, so it's the opposite of positive 31. So that one's gone. 17.2, no, it has a decimal. 42.4, no, it has a decimal. Okay, so I only have one integer to put in here. Then I look at my rational numbers. Rational numbers are everything else. They could be positive or negative, and they can be a decimal or a fraction. So here we have negative 5.7. We have 17.2. And we have 42.4. All of those are rational numbers. Now, remember, everything inside this big diagram is a rational number. Whole numbers are rational numbers. Integers are rational numbers. The reason we only have these 4 in the rational number category is because those 4 are only rational numbers. They're not integers. They're not whole numbers. They're only rational numbers. 6, 0, 125 are whole numbers, but they're also integers and rational numbers, right? Integers, negative 31, it's not a whole number, right, because it's negative, but it is an integer, which means it's also a rational number, okay? So everything in that diagram is a rational number, but some of them are also integers and some of them are also whole numbers. So every number, sorry, I was waiting for the bell and everything. Every number belongs in a specific location on the number line. So we're going to place some. A is negative 8.7. So negative 8.7 is going to go between negative 8 and negative 9. Okay? Negative 8.7. So 8.7 would be between 8 and 9, right? But since it's negative, it's between negative 8 and 9. So I'm going to place a dot between negative 8 and negative 9, closer to negative 9, because 0.7 is closer to 9 than it is to 8, right? So this is my point A. 5.6, B. So that's positive, so I'm going to go between 5 and 6. And 5.6, it's pretty close to the middle, but just slightly closer to 6. So that's where I'm going to try and place it as best I can. C negative 1.1, so I'm looking at negative 1. And remember, you're going to be between the number in the decimal and the next biggest number. So if I have negative 1.1, it can't be over here between negative 1 and 0 because it's bigger, well, really smaller because it's negative, than 1. So I'm going to go negative 1.1 right here, just right after that negative 1, in between the negative 1 and negative 2. D, 3.4, so I'm between 3 and 4, the two whole numbers I'm between there, and it's going to go kind of towards the middle but slightly closer to 3. And then E, 9.3, would be between 9 and 10, and it's going to be closer to 9 than 10. Okay. So when you order numbers, you think, okay, obviously negative numbers are the smallest because they're less than 0, right? And the bigger the negative number, the smaller it actually is because the farther away it is from 0. Positive numbers, if it has a decimal, so we'll look at it here. Negative 6 is my only negative number here, so it's obviously my smallest. So they said from least to greatest, so it's smallest to biggest. So I have negative 6. Then, looking at the rest of my numbers, I have 4, 4.6, 16, and 3.9. So look at your ones place for each one. I have 4, I have 16, and I have 3.9. 3.9 is smaller than 4, right? Because it's less than 4. If I draw a number line, or if I look at my number line up here, nope, that's negative. 3.9 is going to be just before the 4, but not to it. So 3.9 is my next smallest. Then I have 4 and 4.6. Now, they both have the same number of ones, but that 0.6 tells me it's more than 4, but not quite 5. So 4 is the next smallest, then you have 4.6. And then last but not least, you have 16. Okay? So now, we have 1.77, 17, 1.07, negative 4.5, and negative 7. So, first of all, I have two negative numbers. Now, you may be thinking, oh, well, negative 4 is smaller, 4.5 is smaller than negative 7. No. Look up here on the number line. 4 is right here. 7 is right here. 4 is closer to those positive numbers, right? So, it's actually a bigger number, even though we know that 4 usually is smaller than 7. Negative 7 is a bigger negative number, which means it has a smaller value overall. So, negative 7 is my least, then negative 4.5, okay? Now I'm looking at my positive numbers. I have 1.07, 1.77. So look at it by place value. 1.07, 1.77. Okay, the ones are the same, so that doesn't help me, right? Then 0 and 7. Well, what's bigger, 0 or 7? 7, right? 7/10 is more than 0/10. So 1.07 is my next smallest number. Then I have 1.77, and then last but not least, 17. Okay. All right, we're going to go to the next page. So percents can be ordered as well, but in order to order them, first you have to convert them to decimals. So all you do when you're converting by decimals is moving that decimal place. So 25% is 0.25. You just move your decimal 2 places to the left, regardless of if you see a decimal, if there's a decimal in the percent, regardless, you always move it 2 places to the left to convert it from a percent to a decimal. So I'm going to show you what I mean. 50%, 50%, I move it 1, 2, and that is 0.50. 68%, move it 1, 2, that is 0.68. Okay. We're going to skip 6. You'll do that one on your own in the Google form. 33.3 repeating. That line over the top means repeating. We'll talk more about that in later units. But that means it's going to be 0.3, and the 3 is just going to go on forever. But I have 33.3 repeating. So when I move it twice, I have 2. So I have 0.33 3 repeating. Okay, really I could just put 3 repeating, but since we're moving it over twice, I want to include all those digits. Then, for this one, I have a number bigger than 100, right? So I'm going to put my decimal at the end, and I go 1, 2, so my percent, or my decimal, is 1.88. Because think about it, when you look at a test, if you got an A+, you got 100%. So if it's more than 100%, then it's more than one whole, right? You're going to do 9 on your own on the Google form. Okay, this one has a decimal in it and there's nothing here. So when I do this, I move it over 1, 2, I have to put a placeholder here. So my decimal is 0.009%, or 009. And 100%, doop, doop, I move it over, that's just 1. Okay, I could put 1.00, but you don't have to. All right, so now when I order them, I'm going to use this number line to help me. So I'm going to write them all as decimals first. So 55% would be 0.55. This one's already a decimal. This one's already a decimal. And then 100% would just be 1, or 1.00. Okay, so my smallest one here is that 0.55, or that 55%. So I'm going to write it as 55% when I order. Then I have 0.67. I know that those two are the smallest because they're less than 1. The other two have something in the ones place, right? These ones just have 0. Now I have 1.24 and 1. So 1, or 100%, is smaller than 1.24. Because if I change 1.24 to a percent, it'd be 124%, right? Okay. If I were to put those on the number line, 0.55 or 55% would be like close to the middle between 0 and 1, right? Because it's not 1, but it's right in the middle. 0.67 would just be slightly closer to 1. Then you have 1, 100% at 1, and then 1.24 right there. So if I can clearly see on the number line where each of those go, right? So it's easy for me to order them that way. Now, we have negative numbers here. So if negative 0.75, so that's less than 1, right? Or it's less than 0, so it's a negative number, and it's not quite to negative 1, which would be right here in the middle, right? This would be negative 1, this would be 1. So negative 0.75 would go somewhere in here, right? Then you have positive 2, negative 50%. So negative 50%, if I write that as a decimal, would be negative 0.50. So that goes right in the middle between 0 and negative 1. And then you have 1.5, which would be right between 1 and 2. Okay? So looking at this number line, I can see clearly from least to greatest, or from left to right, I have negative 0.75 is my smallest, because it's the farthest on the negative side. It's the farthest away from 0, farthest away from being positive, right? Then I have 50%, negative 50%. Then I have 1.5, and then I have 2. Okay. So I'm going to have you do 14 and 15 on the notes on your own. So read those and answer the questions.